Well, here we go. We are ready to move on to chapter 10, which is, I guess I'd say it's a fairly important chapter for, for at least one reason. Um, as I mentioned at the beginning of the chapter, 9 notes philosophies and theories related to perception have been a common theme in this class so far. And that relates back to some things that I might have said in the first couple of chapters with debates centered around whether or not we can trust our senses being at one of the main forefronts of these philosophical questions. And that really does have a big effect on how we think about mind. Some of the assumptions of dualism, for example, are designed to keep our perceptual realities and our minds somehow disconnected from reality. And when you do that, it raises all kinds of questions about where does knowledge come from? And of course, that leads to rationalism. If we think that, oh, the senses are completely useless in that regard, then we don't want to have knowledge from the senses, and we are left hoping that we have some kind of innate knowledge and reason and logic and mathematics and all of these things that we have at our disposal as a way of arriving at the truth of the universe, since we can't trust the senses. And then you get the blank slate empiricists of chapter 5. Let me just jump into this actually, because before I keep on talking, that's what I have on this slide. And so just here are various examples of stories and allegories and things that we have discussed in this first half of the class, most of it, at least in the first 4 to 5 chapters, of examples of why people think we can't trust the senses, right? We had all of Zeno's paradoxes suggesting that concepts like distance and motion are illogical because it doesn't really match the mathematics, and they place mathematics as a higher truth. Right? It's logical and systematic, and if anything contradicts mathematics in the way the concept of a finite distance and motion appear to do, if you want to go with Zeno's reasoning anyway, then we would be left concluding that it's the distance and the motion ideas that are wrong, not the mathematics. And since the argument is that these ideas of distance and motion arise only from our senses, it therefore is left to imply that it's the senses that are giving us all kinds of bad ideas, right? So this issue of distance and distance perception and whether or not it's real or not has been a common theme. We saw it in chapter 5 when we were talking about Berkeley's attempts to discuss distance perception. Hume, of course, remained a skeptic about things of that nature. We talked more about concepts like force and cause and effect for Hume, but he would have applied the same logic to distance, suggesting that there's no way for us to know whether or not these ideas correspond to anything real or not. And so this is a common theme. And of course, Descartes with the whole brain in the vat, that corresponds to the story behind the movie The Matrix, which in and of itself is all just a restatement of Plato's old allegory of the cave. And basically any theory in which we talk about perception as a form of translation. So that's a common theme that I use in discussing these topics, is that when we suggest that appearance is not reality, what we're saying there is that something happens in converting reality into perception or translating reality into perception. Something is lost, something is changed. And that's really encapsulated by the difference introduced by Galileo between the idea of a primary quality, which is a way of describing reality, things as they are. And that also is similar to Kant's ideas of the noumenal reality, things as they exist. But then there's things as they are perceived, which is what Galileo called secondary qualities, and it's what Kant called the phenomenal world. And the idea is that phenomenal reality is very different than noumenal reality for Kant, right? It's got its own kinds of things. So going back to secondary qualities, properties of visual experience like color and brightness are in fact just properties of visual experience. They're not properties of objects. Objects reflect light, but that's not brightness and color. Objects can create vibrations in the air, but that's not pitch and loudness of sound. Those are secondary qualities. Those are phenomenal experiential kinds of words, right? So to use the language of the phenomenologists, especially the Gestalt psychologists, they want to talk in terms of experiential qualities. What do you see? You see color, you see brightness, you see edges, contours, and shapes. What do you hear, right? And those kinds of qualities are different than what is present in the sensations. So there's some kind of translation, conversion, something is added in, right? And because there's this barrier between reality and perception, we sometimes are left with a lot of skepticism, right? So we either have here at the bottom of this slide, the rationalists who try to maybe save us from skepticism by invoking innate knowledge. They say, okay, yes, we can't trust the senses, but good for us. We have innate ideas, we have innate knowledge, like Plato, for example, or even Kant with his the innate categories. And of course, we have reason, logic, and mathematics, and all that stuff can save us from the skepticism implied by the possibilities that we cannot trust our senses. But what if you're an empiricist? If you're an empiricist, you're going to say, we don't have that stuff. We don't have innate knowledge, right? The only thing that we can know is what our senses are telling us. And at that point, you're left with two choices. You either trust your senses or you don't. But so far, pretty much everyone we've been talking about has still been suggesting that we still can't trust the senses. So even if you're born a blank slate in the way that Locke had argued, if there's still some reason to doubt your senses, to think that maybe what you experience is not exactly the same as what's real. And of course, Locke was a dualist, and he did accept that primary versus secondary distinction. And he said that what happens is that we just receive simple ideas and we have to construct an internal reality from simple ideas, building them up into complex ideas based on laws of association. And then Hume is taking that and he's running with it, and he's saying, you know what we're left with here are a bunch of complex ideas that were just built up out of associations, but we have no way to ever verify whether or not these complex ideas that we have created in our minds, we have constructed a perceptual reality in our minds, we have no way to ever verify if that's real. How do we do it? Again, it's that translator problem. If you're speaking to someone who speaks another language and they say something to you, you have no idea what it means unless you have a third party, the translator, who comes between and tells you what the other person has said. But at that point, you're left with the question, can I verify what the translator has told me? And if that's all you have is just the one translator, you're at their mercy. Right? You have no way to know if they're telling you the truth or not. And so Hume is basically arguing that what we know is only what the quote unquote translator has told us. And then in this case, the translator is whatever process is converting from sensation to perception. Right? It's step 3 in that big four-stage perceptual theory we made a big deal about in chapter 6. And we discussed it again briefly in chapter 9 with the Gestaltists. So in what I've described at the bottom here is that Hume is the culmination of this kind of empiricist skepticism, right? He's really the first one to, I think, point out the ultimate implications of what this idea is suggesting here. We either have innate knowledge and to allow us to know anything, or we don't know anything. And so Hume, by making that claim that we can only know what's given to the senses and there's no other knowledge available to us, we're left concluding that we cannot trust the senses and we're skeptics. So it seemed a point that we want to return to rationalism. That was certainly why Kant had tried to revert back to rationalism. And that was why the Gestaltists were doing what they were doing as just an extension 100 or so years later on what Kant was trying to say. So we have a few possibilities here. As we have mentioned, Hume is a skeptic, and he's also really a nominalist, right? And nominalism are the ones who are saying that the ideas, the categories like circles and dogs and cats and red and blue and green, all these categories that we have in our minds are really just mental categories. They don't correspond to anything that's real, all right? But we don't really like that. We want to be realists. I think maybe intuitively, I hope that that makes sense. We want to believe, and therefore we want to find a philosophy or a perceptual theory that would allow us to accept the possibility that our knowledge does correspond to things that are real, that what we perceive is in some way real, that distance is real, that we're perceiving a real world around us, that it has real properties, that has distance, right? And so forth. So we want realism. But so far, our knowledge of the world, if we're going to try to make a justification for realism, is still indirect. Why am I going to call it indirect realism? What does that mean? This might have come up a little bit briefly at the end of chapter 5 when we were talking about the translator problem before. The issue here is, just like, again, let's go back to our example. You have a translator. You're speaking to someone who speaks another language. A translator comes between you, and they listen to what the other person has said. They turn, they face you, and they say something that you can understand. And now the question is your knowledge of what the other person speaking the other language, do you directly know what they have said? And the answer is no. You only indirectly know, because you only know through this intermediary, right? There's this intermediary between you and the other person who speaks that other language. And so that's what we mean by indirect knowledge, right? And so in this case, because the sensations and whatever processes help convert sensations to meaningful perception, that's our translation. And if that's our only knowledge, right, again, our knowledge of reality is now indirect, right? It only happens through the intermediary of sensations. And so this is why in modern psychology, these kinds of theories are often referred to as sensation-mediated perception, right? Because in this case, the idea is that all of our perceptual knowledge is really mediated by the incoming sensory data. And as we have discussed previously, the incoming sensory data is generally described as being impoverished. So it's that old poverty of stimulus argument, again, that the incoming sensory data just doesn't contain enough information to actually tell us about what's real, and that we have to then correct for that and add more to it. That's certainly the big theme of the Gestalt in the previous chapter, right? Is all of the stuff that gets added in to fill in all the gaps, right? The law of prognance. So we have to interpret it. We have to translate it. We have to fix it. We have to enrich it. But at this point, we're left with a choice, in a sense, of whether or not we're going to just trust the translator, which means to trust the senses, or not. And we're faced with that choice. What we could just choose to trust the translator, but can we really justify it? Can we justify this just sort of an unquestionable assumption that it is correct? That's certainly something that Thomas Reid, back in chapter 5, and so far Reid is the only one who has really tried to give us a theory that we might call direct realism, right? We called it naive realism in chapter 5. We could also call it direct realism, because it assumes that we don't have to worry about whether or not we can trust our translator. But his appeal is an appeal to common sense. And you might just suggest that maybe common sense is not a good enough argument. That maybe just because I look at something and say that looks red, and you look at something and also say, yes, I agree, that looks red, that there's no guarantee that we really have had the same experience. All right. How do I know that the way in which I experience that color is exactly the same way that you experience it? Maybe we all have different, quote unquote, now going to Kant, phenomenal experiences happening in our minds, and they're not the same at all, in which case that's not realist knowledge at all, right? It's purely subjective. So how do we trust our translator? Can we justify it? Certainly Kant had tried to do that by suggesting that his innate categories are somehow grounded into the physical properties of the brain having some special status as both a part of physical reality, but it's also the thing that creates our conscious minds, and therefore it gives structure to our conscious experiences. And now our experiences are grounded in that reality of the brain itself. 100 some years later, the Gestaltists are saying very much the same thing, though they change it by talking about the brain fields, but they still make an argument that the brain fields are grounded in the brain's reality. Helmholtz there in between them has made an argument that we can trust our translator because we have our past experiences, and his argument is that our past experiences were successful to the extent that they enable us to actually live, right? The idea is that because we're able to successfully use our past experiences to make predictions about what's going to happen next, and what I think the world is going to be like. If I start walking across the room, I see certain visual patterns, such as the way the floor appears, and that enables me to predict based on my past experiences that the floor is level and solid and I should be able to walk on it fairly well. And in fact, that turns out to be the case, that I'm actually able to maintain some sort of a stable, coherent, a perceptual reality drawing from those past experiences, and it enables me to actually survive. I'm actually able to get around in the world, get where I need to go, and get the things that I need, and to eat and sleep and have shelter and all those things. So far, life has appeared to be successful, lived to be this long, so therefore I must be perceiving something pretty accurately in order for that to be the case, right? That's Helmholtz's argument, is that the fact that we are able to continue functioning is sufficient justification to accept the fact that our past experiences were successful, and therefore something that could be relied upon to tell us what's real, what's going on. Even still, there's possibility that that's all perhaps just an illusory reality that just happens to be good enough to enable us to interact with a real reality, but there's still some dividing line between the way we experience things versus the way they really are. And so there's still possibly a little room for skepticism there, though Helmholtz's argument is generally seen as a fairly good one, at least among a fair number of cognitive psychologists. But is there an alternative? Is there a way in which we could talk about direct realism that avoids having to go through all of these, maybe jump through all of these hoops in order to find ways to justify whether we could trust this process? As I had mentioned, we saw that Reid was trying to make an argument for just naively accepting what our senses tell us based on common sense. But again, maybe it would be better if we had a more scientifically grounded theory. And this is where the work of the 20th century perceptual psychologist James Gibson, or J.J. Gibson, comes in. So here I've got the theory titled The Ecological Theory of Perception. It may not be immediately clear why it's called an ecological theory, but I'll try to get to that as we start to explain the theory. But it's an example of what we're going to call direct realism. And I want to emphasize, I think, right off the bat, that the key thing that you need to understand here about Gibson is that where he changes things when it comes to how we think about perception, if you think back to the four-step theory, right? So four-step theory is that number one, we have a world out there to be perceived, but at step two, we get a bunch of impoverished, meaningless, and insufficient sensations. And then in step three, we have to translate them. And then in step four, we get meaningful perception. So far, a lot of these perceptual theories have just been debates about what happens in step three, right? Is it a bottom-up approach, top-down approach? If it's top-down, is it based on innate knowledge? Is it based on past experience, right? All of these debates. Gibson is not arguing about step three. Gibson's arguing about step two. And that's what makes this theory very, very different. In a way, it's really almost a radical step, because he's suggesting here, what he's rejecting really is the poverty of stimulus argument. There is this long-running assumption that he's primarily working in the context of vision, but we could apply this to all the senses, that the visual inputs are impoverished, right? That they don't provide enough information about the world. And his argument, based on various ways of trying to redefine the nature of how the visual system works, is that there actually is plenty of information coming into the eyes. And this is where it's called the theory of ecological optics. So the idea that optics is used here as a way of describing light, and the fact that we use light to see the world, right? That light illuminates our environment, it reflects off of surfaces of objects in the world, and then it makes it into our eyes, and our eyes extract information from that light pattern, from those light patterns, right? And that's where the ecological side also comes in as well, because Gibson is making a big deal about the fact that we live in an environment that is richly saturated with light as a source of information about the world. And so when we think about ecology, we oftentimes think about the environment that animals live in that provides for their needs, like food and shelter and stuff like that. But Gibson is making the argument that light and other forms of things that stimulate our senses are also part of our ecological environments, and that we have evolved sensory organs to extract information from those ecological patterns, right? Just like we have hands that we have evolved for grasping objects, and that we have evolved arms and legs for moving around, and we have evolved teeth and jaws and mouths for eating, right? All of the things that we can do with our bodies. We have also evolved perceptual systems to help regulate all of these movements of our bodies. And that's all tied to environmental stuff. It's all tied to our ecology. That visual systems evolved the way they did because of the light in the environment, and that the visual systems evolved for the purpose of extracting information from the light in the environment. And we could also then make a same argument about hearing. Some people have done this in the years since Gibson, theories of what would be called ecological acoustics, and talking about how the auditory systems could have evolved to extract meaningful patterns in sound vibrations, right? So now what we're talking about here is the idea that perception is tied very much to the physical properties of the environment. So when we do that, I hope you're really connecting the dot here, is that this is very much a rejection of dualism, because it's really taking the mind and it's tying it in a way that's very much influenced by Darwin's theory of evolution, connecting the mind to our environment. And that's why it's an ecological theory of perception, is that we are now animals in environments. And that includes not just our bodies, but it includes our minds and our perceptual reality. That is the most crucial component of Gibson's theory here, is the fact that perceptual reality becomes part of our biological connection to our environment through evolution. And it's in this way that he can now reject step 2 in the 4-step perceptual theory, that the input is impoverished. And if we do that, that very much changes what has to happen next. Do we even need a step 3 anymore? Right? If we reject the idea that sensations are meaningless, then that means we don't necessarily, or not even at all, need a 3rd step that involves interpreting or translating or adding meaning in. The meaning is already there, right? It's coming in. We are extracting meaningful information from the environment. So that means that the next step would just be conscious perception, right? You get to go from things in the world to meaningful input. I don't want to call it even sensations anymore. I want to call it something else. I want to call it here, as Gibson has, ecological optics, light coming into the visual system. And then we have perception. So this would really be a 3-step theory now, right? We don't need that processing step anymore. We just have world, information, and perception. Those would be the 3 steps. Let's have a look here. So the ecological theory is, again, the idea is that information for perception, right, what we're going to call our knowledge now, it comes from perception. So this is an empiricist theory for sure. That information is not to be found in sensations. We're not going to talk about sensations, especially the so-called meaningless sensations, and all of the things that we've talked about in terms of retinal images and why they are problematic. You know, they're flat and 2-dimensional, but we perceive a 3-dimensional world. That's usually invoked as one of the reasons why we think of the sensory input as impoverished, right? And Gibson says we don't really need to talk about retinal images, that's not really the starting point for vision. It's just a stage of neural extraction of information but it's not the starting point. The starting point for perceptual information is in what he calls ambient stimulation. And that's just a fancy way of talking about the light, right? So when I say energy arrays, we're talking about light as a form of energy, right? It is a form of energy. It's electromagnetic radiation. And it's an array because there's a lot of light, right? If you think about it, think about the room that you're in now, the environment that you're in now. There might be computer monitors, in my case, and walls behind it, and a hallway to my right with doors, closet doors, and a cabinet over on my right as well. Light is illuminating this room, and light is reflecting off of those objects. And when the light reflects off of those objects, it gets its change in a way, right? So Gibson, one of the things that Gibson does is he says we should try to emphasize a distinction between what's called radiant light and ambient light. Radiant light is homogeneous. And to be homogeneous means it's the same everywhere. And that also then means it contains no structure, it contains no patterns, it contains no information. And therefore, radiant light is actually not useful for seeing. It's because it doesn't carry any information, it wouldn't really be useful for perception. Radiant light is the kind of light that's emitted by a light source, whether it's a light bulb or a sun, it's just photons of energy. But when all of that radiant light interacts with a surface in the environment, it reflects off of the walls. It changes, right? Those walls reflect the light. And in the interaction with the light and the surface of the wall, that light becomes changed in a certain way. It gets reflected, and some of those wavelengths in the radiant light are absorbed by the pigmentation, the paint on the wall. Some are reflected. And the way in which it's reflected differs as a function of the texture of the wall, right? Some surfaces are kind of matte surfaces that diffuse the light in many directions. Others are more glossy, and they create what are called specular reflections, and they create that more glossy kind of dark or direct kind of reflection. So glassy metallic surfaces, for example, look different than a textured painted wall, right? Because of the way in which the light is diffused across the room at the point of reflection. So it is this interaction between radiant light and a surface that then creates ambient light. And ambient light, which is the light reflected from a surface, contains patterns. And it's these patterns are specific to the surface that it's reflecting from, right? Again, different surfaces reflecting light in different ways. There are, in fact, physical principles that govern this process, right? It's principles related to the physics of light. And so therefore there's a real lawful, that's an important term here, that there are lawful relationships between patterns in the ambient light and certain properties of surfaces that that light has reflected from. And now Gibson's argument is that if we have a visual system that has evolved in this environment full of this ambient structured light, and it's able to extract information and patterns from that structured light, it gets information about surfaces for free. And so that's the important point here, is that the patterns in the light, here's a good way to think about it. The patterns in the ambient light have a one-to-one relationship with some property of the surface they've reflected from. And that one-to-one relationship is important because it means that you don't need to guess or infer the surface that's reflected from. If it was an ambiguous kind of many-to-one relationship, well, what that would mean is that many different surfaces could have created the same light pattern. And that would create ambiguity in your incoming stimulation. That's the classic way of talking about vision, and the idea of an impoverished stimulus is the idea that there is ambiguity in the incoming stimulus. Many different situations could have created the same visual pattern, and now I just have to guess at which one it was. That's certainly the entire idea behind Helmholtz's unconscious inference, is that past experience will help me make a good guess about which is the appropriate inference to draw. But Gibson's making the argument that if we focus more on patterns in the ambient light rather than retinal images, what we'll find is that there are patterns that are inherently meaningful because they are connected one-to-one to properties of objects and surfaces. That means we don't have to guess at them anymore. We just have to have visual systems that can detect the structure, and we get perception of the objects, again, quote unquote, for free. That is, we don't have to do any extra work. We don't have to have any kind of extra internal processing. We just perceive the world via light, right? And because of that, we get direct perception that is unmediated by meaningless sensations. And because of the one-to-one lawful relationship between light and the world, we get direct realism. We get to say that this knowledge corresponds to real properties of the objects that reflect the light. And that's how vision works. We see via reflected light, not by radiant, unstructured, homogeneous light. We see by ambient, heterogeneous, patterned, structured light. Gibson, in fact, calls this the optic array. The optic array being, well, another way of talking about this so-called theory of ecological optics, all of these light rays converging to your eyes, coming from many different surfaces all at the same time. So again, think about the room that you're in, the walls, doors, desks, computers, whatever it is that you have around you. Light is reflecting from all of that stuff and entering into your eye at the same time. And that creates an array of light rays, right? And that's what he means by the optic array. One way to try to visualize this, I admit it is difficult to visualize it, but this drawing here, which can perhaps be a little confusing, let's not worry about optic flow just yet. Let's first just think about optic array. And if you understand optic array, hopefully optic flow will then be a lot easier to understand. So this is meant to be a convenience, this bird flying over a field. So that's what we're looking at here. Birds flying over a plowed farmer's field. Those are furrows down on the ground, right? There's this hemisphere surrounding the bird with the bird's eyes will be right in the center of it, right? Now, this is just meant to be there for the convenience of helping us visualize what the bird's optic array is like. There's, the theory doesn't say that there's really this sphere out there. This is just a way of trying to capture it and describe it and to try to draw it. So what I want you to do, if you can follow my mouse pointer, hopefully it's working on the recording. I've got it pointed here at the nearest end of one of these plow parts of the farmer's field, these furrows, right? We have to imagine that there's light reflecting off of this point, and it's going to make it, so you trace my mouse pointer in an approximate, hopefully straight line to the bird's eye. So that light ray, a single light ray reflecting from one point on the field is going to travel in a straight line directly to the bird's eye, right? So just like that. I'm going to try something here. Maybe this will work. Just like that. Now, along the way, if we imagine this hemisphere that's surrounding the bird's eyes, we would realize that the light ray intersects that sphere at some point, right about here. I didn't quite make it. I was hoping I might be able to get that to be right at the base of one of those arrows. Maybe I'll just move it just a little bit to make it there. How about that? So I got that intersection, if you can imagine it, right there at the base of this arrow, right? So if the bird was frozen in midair, not actually moving, right? Then that light ray, as it intersects this imaginary hemisphere, would just leave a dot on that hemisphere, right? And of course, because there's many other visible points in the bird's field of view, they would all leave dots somewhere on the hemisphere. And if we traced all of those dot patterns on this hemisphere, you would start to notice that there are certain patterns occurring in the arrangement of all of these dots. And it's the arrangement of all of the dots that is literally what we mean by the optic array. It's the arrangement of all of the light rays as they are nested together, as they come together, all converging at one single point, which is the bird's eye. So I could draw a whole bunch more arrows just like that one, but I don't want to do that. That's just going to clutter up the scene here. One of the things that we might notice, for example, is that the arrangement of all of those dots leaves a pattern that would create a texture gradient. And a texture gradient means that the spacing of the dots will change as a function of the distance of the furrows. So you can see the furrows on the field here get farther and farther away to what would be the bird's left, right? And what will happen is that the dots get more and more compressed in their arrangement on the sphere as they get farther and farther away from the bird, as they come from places in the world that are farther and farther away. Those texture gradients provide patterns that are inherently informational about the spatial arrangement of the ground plane, right? That it's getting farther and farther away, further off to the bird's left, and tells the bird something about the spatial distribution of the furrows in the field and any other objects that might be visible. They can be localized at some distance in relation to everything else. But of course, the bird technically is not frozen in midair, it's flying. And that's where these arrows on the hemisphere are drawn for a reason, is that as the bird actually begins to move over the field, these points are going to trace out arcs, right? So what's going to happen is that as the bird flies forward, it's going to move in relation to stationary things on the ground. And now what happens is that the point on the hemisphere travels from the initial position it was at to some new position. Now I've moved it to the tip of that arrow. And that creates what's called an optic flow vector. And it describes the visual motion that the bird experiences as it moves past some stationary thing in the world. You can experience this as easily as just placing an object on a desk in front of you and walking past it. And you will notice, of course, that visually it drifts off to your right or to your left, depending on which side it's on as you walk past it. And that's what we're seeing here. Each of these arrows represent the optical motions, the optic flow of stationary positions in the world as the bird flies past them. And they all flow to the bird's left as the bird does so. And instead of what we called a texture gradient, now what we have is a flow gradient, right? And we notice some patterns such as the fact that the arrows get smaller and smaller and smaller the farther up they go. And that's because these top vectors that are smaller than the ones down at the bottom come from furrows that are farther away. So think about that. If you've ever been in a car and you look out the side of the car and the stuff right on the side of the road, hopefully you're the passenger and you're doing this, right? You look right at the side of the road, everything is zipping by really fast. But if there's a field next to you and there might be a row of trees a quarter mile away on the other side of the field, everything on the other side of the field looks like it's moving more slowly compared to the stuff right there at the side of the road that's zipping by, even though you're still traveling the same speed relative to all of it, right? If the car is locked in at 50 miles an hour, you're moving 50 miles an hour past the stuff right there on the side of the road. You're moving 50 miles an hour relative to a tree that's a quarter mile away. But how come the tree looks like it's moving more slowly compared to the gravel on the side of the road? That's because of the distance. And the optic flow vectors get shorter and shorter, meaning that they travel less distance in the bird's field of view over a given amount of time, meaning they appear to move more slowly. So this creates a flow gradient. And this flow gradient now provides information also about distance. Notice also that all of these vectors are radiating out from a central point here. The bird's traveling in this direction. And all the flow vectors seem to originate out from that point. That's called the nodal point or the focus of expansion. And that actually provides information to the bird as well. It provides information about where the bird is traveling. It tells the bird that whatever object in the world that focus of expansion is sitting on top of, that's where the bird will actually arrive at. So if the bird wanted to land on a tree branch, they would be able to control their flight to steer to keep the focus of expansion of all the optic flow vectors right on the tree branch. And as long as they steer that way, they are guaranteed to head towards the tree branch because that pattern is inherently informational. And if you wanted to walk towards the door, you could control your optic flow vectors to keep the focus of expansion centered on the door, and that will guarantee that you arrive at the door and you don't walk into a wall somewhere else, right? So the point here is that what we're doing, if some of this stuff is a little too technical and confusing, there's a lot of geometry and math behind actually drawing these things. Um, the point here is that these patterns of light are inherently meaningful. And because they're defined outside of the bird, right? This is not meaning that has to be created inside the bird's brain somewhere, inside the bird's mind. It doesn't need past experiences or innate knowledge. This information is out there in the world to be perceived. And all the bird needs is a functioning visual system that can extract these meaningful patterns. And it will get the information, again, for free. And once it extracts the information, it can control its flight through the world, driven by the information without processing, right? Some other patterns here. Here we've got a person. Again, we've got our imaginary sphere centered around the person's visual system, their eyes, their head. We can imagine that there's light rays coming in from all directions. So other questions, other meaningful patterns that can be found. Sometimes when we experience visual motion, we might ask the question, well, can you tell what's moving? How do you know it's an object that's moving versus maybe it's you that's moving? In the case of the bird, we are assuming that the bird is moving through a stationary environment. But sometimes it might be the environment that's moving, not the bird. And that could be ambiguous, right? How do we know what caused the visual motion? Was it object motion or was it self motion? Gibson has a claim for that too as well, that when we move, this creates a unique pattern of optic flow called down here at the bottom global flow. So this is the person's view from inside the sphere. All of those optic flow vectors for their entire visual field are in motion. But if the person is standing still and someone does something like bounces a ball towards them, they experience what would be called local flow, where most of their visual field is stationary. There's no optic flow present except for within this one little local area that corresponds to the ball coming at you. Notice, of course, that the ball itself has a little focus of expansion on it, telling you that the ball is coming right at your face. If all of these vectors on the ball were actually parallel, kind of pointing to the left or to the right, that would actually be information telling us that the ball is going to pass to the left or to the right, as opposed to coming right for you. So there's actually a whole lot more information. And if this was a different class, I might go into the details about how there's information here about time to contact, how much time before the ball hits you is actually something that we could demonstrate is available based on optic flow patterns. The upshot of all of that is right here. What we have is the idea that the information for perception is now in the world. We don't need to store it in our head. We don't need to have innate knowledge, and we don't need to have past experiences. And that means that we don't have to engage in the kind of top-down processing that Kant or Helmholtz were talking about, or the Gestaltists even were talking about. We just don't need to do that. We don't have to have all of that kind of pre-existing stuff in order to make sense out of the world in the current moment. But even though we're rejecting top-down processing, I don't want you to get misled and think that this is actually a bottom-up theory, because in the bottom-up processing theories, like what Locke and others were talking about here, that still was working on the assumption that we're starting with some kind of meaningless sensation, and we just construct based on a bottom-up process like the laws of association, and we construct an internal perceptual reality or perceptual representation based on that data. Because this doesn't ask us to do that either. So when it comes to the debate between top-down and bottom-up, what Gibson's theory is doing is he's rendering that debate moot, right? It's just obsolete. It's not top-down versus bottom-up anymore. It's neither. It's no processing at all. So that's why I said it's not really a four-step theory. Remember, the old four-step theory is objects, meaningless sensations, some kind of processing, and then perception. But for Gibson, it's objects, information, and perception. We don't need the processing stage anymore. We just need information detectors. And that's what our sensory organs are now conceptualized as being. The visual system is something that evolved to extract information from the optic array. The optic array exists whether we're there or not. So this is another way of dealing with the whole if a tree falls in the forest kind of question. I mentioned that some people in the time since Gibson have tried to create a theory of ecological acoustics, right? So we would say that the ecological acoustics are there regardless of whether someone hears them or not. And since hearing is directly tied to the qualities of ecological acoustics, there's no dualistic distinction between those two things anymore. So if you're Gibson, the answer is yes, of course, a tree makes a sound, because sound is directly tied to the acoustic patterns of the vibratory waves created when the tree falls. And of course, yes, the tree was green, because your perception of the color of the leaves is tied to the ecological optics of the way in which those leaves reflect light. It's realist in its nature in terms of how we perceive everything. So now we get direct access to what we have previously called primary qualities. So we don't have to really think about secondary qualities anymore as being somehow a different thing. And of course, if we don't need to talk about secondary qualities, we don't need to call primary qualities primary anymore. We could just call them real qualities or real properties of objects, right? We perceive the real properties of objects that reflect light. We don't need any kind of translation anymore. We don't have to rely on past experience or innate knowledge. And this is not dualism. So Gibson's theory has really been a theory that helps move us away from dualism. We've seen, going back to Descartes, that this kind of dualism leads to some funky stuff, and we don't like it. Philosophers in general will try to reject dualism whenever they encounter it. And but not all psychological theories have successfully done so. And that's one of the problems with the idea of indirect realism as a theory, whether it's Helmholtz or others. There's that little dualism in there. And if we really want to get rid of dualism in psychology, then a direct perceptual theory would seem to be necessary for that. Well, I have the 3 steps here that I've already been talking about here. So again, objects in the world. If we're talking about vision, then we're going to talk about visual information in the ambient light, in the optic array or the optic flow patterns. It's inherently meaningful. It's not an impoverished stimulus. So therefore, nothing has to be added in. Nothing has to be processed. So step 3 is that we just detect the information with our visual systems, and that equals perception without any extra work, without any extra cognitive steps involved internally. Something else that's important about this, I was mentioning before about the evolutionary connection to Gibson's theory and how we evolved arms and legs and all of our moving parts so that we can interact with the world physically. And Gibson's argument is that perception is an important part of all of that stuff, because we need perceptual inputs in order to be able to control our movement in the world. So his argument is that you cannot really separate the study of perception from the study of how we control our bodies, and that's what we call action. In old-fashioned psychology, there's a whole area called motor control, which is much more of a process that just focuses on the nature of how the brain controls the muscles and causes them to contract. But it tends to ignore the role of perceptual information that's obviously necessary to determine exactly how we should move, right? If I want to reach out and pick something up, I kind of need to know how far away it is. And that certainly plays an important role in the kinds of muscle contractions that are necessary to get my hand out there. So all movements have to be very carefully coordinated by perceptual information. And this is where Gibson is kind of changing that aspect of psychology too. And so it leads to the study of something called perception and action as a kind of a singular unitary area of studying. You just don't study perception all by itself. And you don't study motor control all by itself. You have to study these 2 things as if they're actually part of a single system. So here, what we say here is that, a good quote from Gibson there at the bottom, the first half makes a lot of sense. We perceive in order to move, right? That makes some sense. We wouldn't be able to have coordinated movements in the world without perceptual inputs. But also, he argues, we move in order to perceive. And that part maybe catches us a little bit by surprise. And that's why it's called the perception action cycle. Without movement, Gibson argues, is that we really would not be able to generate the perceptual information that's the most useful. So this is why Gibson makes a big deal about talking about optic flow rather than the stationary or static optic array, because optic flow comes when we move, right? The bird is not frozen in midair. As we were drawing it, it's actually flying over the farmer's field. So that means that it is in the act of movement that we generate perceptual information. That perceptual information then is used to control the next movement. And that movement generates more information, which then controls the next movement. And so perception and action continuously unfold as a never-ending cycle, and it never stops. Perception is always enabling an action, and that action is generating new perceptual information, and on it goes, right? We cannot decompose that loop to components. It's one whole system, right? And Gibson also makes a big deal about what the nature of the perceptual information is in terms of how it's useful for generating information that we need for controlling our actions. And Gibson says that the real objects of our perception are things that he called affordances. So he coined this term to describe the idea that when we perceive the world, what we're really doing is we're perceiving the opportunities for action around us. We are perceiving things such as, I can stand on this floor because it's level enough and stable enough to support me. So I'm perceiving the affordance of standability. I perceive that I can walk through a doorway because it's of the appropriate size for me to fit through. So I'm perceiving the passability of that aperture. I perceive that a small rock, as we have in this drawing, is graspable, something that I can pick up and hold in my hand. If you take any verb and add the suffix able to the end of it, a doorway is passable, a floor is standable, a rock is graspable, then you have an affordance, right? So we perceive that all around us, that we perceive the opportunities. A chair is sittable. You know, one of the things that cognitive psychology sometimes deal with, we've been talking all about it this whole class, categorization, right? A lot of times cognitive psychologists will struggle with things like what makes a chair, because chairs come in all kinds of different shapes, right? We have regular desk chairs, you have recliners, you have stools, you have all kinds of different chairs. There's an endless variety of chairs. They have all kinds of different physical characteristics. And if I were to say, what are the specific characteristics that define chairness, it would be difficult to identify what that characteristic is. But if you take an affordance related approach, you would say, well, it affords sitting. And if it's something that affords sitting, it can be a chair, which can, of course, then explain why we can sometimes say that a tree stump could be a chair, because even though it's not even designed to be a chair, it wasn't manufactured, you can still sit on it, right? We can even go back to maybe our concept of dogs. We said before, what makes a dog a dog? Is there some affordance in terms of how we can interact with a dog that defines its social affordance, its relationship with humans, that we can interact with dogs in ways that we don't interact with cats, and any dog owner and cat owner would know very much what that is like. And likewise, different between those two and any other, you know, undomesticated wild animal, right? So maybe that's what makes a dog, is its social affordance, right? Notice, of course, then that the affordance that an object affords to an animal is unique to the animal's abilities as well, right? So the affordance is not necessarily a purely objective thing. It's something that is relational between the perceiving actor and the object. So in the case of this rock, for example, for the human, it is graspable and from there throwable and so forth. But it's from the perspective of the mouse, it's not a graspable object, but it is something else. It could afford climbing, right? Or it could afford hiding and shelter. From the perspective of the cat, it might afford investigating for, you know, maybe it's hiding something, so it affords searching. Even predator-prey relationships, like between the cat and the mouse, could be described in terms of specific kinds of social affordances or interactive affordances, interactional affordances, perhaps. All right, well, that wraps up chapter 10.